we got this thing, here's the center C. And we're going to use this as kind of our pivot right there. Because at this instant, everything is pivoting about that point.
There shouldn't be anything there at 0, right?
Yeah, so the velocity right here is 0. Because essentially at this instant, it's just pivoting right around that point. So we have to use this distance here from there down to there. And our V equals omega R formula. So to find the angular velocity of this whole thing,
isn't it just 2?
What's the distance from there to there?
1 foot.
Oh, really?
Yeah.
Huh.
Or wait, from where to where?
From the bottom.
Not from C?
No.
Oh, not from C. Okay, if it's from C, not from C, it would be 1.5.
So you actually got to do,
Does it be
yeah,
from
one.
here to here plus that? So it's
Exactly,
1.5.
1.5.
Okay. I see what you're doing now. So 1.3. 333.
Yeah. So that's 1.33 radians a second.
Okay.
Now if we look and if this does not help, just let me know and I'll stop talking about it. So when this thing pivots essentially, this point here moves to here, and this point here moves to here. And so they've traveled different distances, right?
How'd that C move? If it was the center?
Yeah, it's kind of,
It really doesn't make sense.
alright, I'll try something else then. Well, Yeah. Alright, now let's stick to that actually. So what you kind of have to imagine this isn't on the same thing. What you have to imagine is that this whole circle is just pivoting around this dot. So it's not rolling down, it's just pivoting about the dot.
Oh, I see what you're saying. So it's just rolling around the dot.
Yeah, so the new one's like that or something.
Okay.
So then the center is now here,
Okay.
and this point is now here.
Okay.
So the key thing there is that they traveled different distances, right? This one traveled farther than this one, but the angle here
Still the same.
is the same, which means that's an angle per time, that angular velocity. So anywhere on this circle, doesn't matter if it's here, 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 they all travel the same angle and the same amount of time.
Okay.
So omega is constant, which means that now that we know omega, we can say VC is equal to RC times the constant omega.
Okay. What's the C for?
Subscript for the center.
Oh, okay.
So what's the radius from here to here?
1 foot.
1 foot, alright. So we got 1 foot times 1.33 feet per second is equal to VC. So velocity C, 1.33 feet per second.
Huh. That was understand when I looked at it, okay.
So the key, kind of key there is it's all pivoting right about that, what's called an instance.
So it's literally like just essentially pinning it to that point and just moving.
That's a way to think about it, yeah.
Okay.
Because obviously it's actually rolling.
Yeah.
But since we're looking just at this instant, you can kind of think of it like that.
Okay. So we went to VC, to RC, and velocity. For VC, that was 1 foot. That's 1.33. So how come you switched from radians per second to feet per second?
Because I messed up.
Okay, so what is it, radians per second? Or-
Yeah, this is radians per second.
Okay.
Thank you.
So then it would be radians feet per second.
Yeah, except radians don't actually exist.
Okay.
They're unitless.
Okay.
Or what they are is, technically it's, so if you look at S equals theta R, you got that formula there, right? So this here is an angle. This is a distance, this is a distance. So theta equals distance over distance, so they cancel out.
Okay.
And we just say it's a radian, but really there's nothing there.
Okay.
They're kind of weird.
Okay.